Hi. Tyler, you muted if you can hear me.
Yeah, I'm here.
Oh, good. Good, good, good. How's life treating you in this isolated times?
Not great. I am really tired.
Oh,
I don't
really?
like being isolated.
Why? Have you been out doing a lot of stuff or what?
No, not quite. I just don't like being inside too much.
Yeah, I know the feeling. I've been a little antsy myself.
Let me see if I can see the paper.
Yeah, it's been wacky trying to get everything online too, because I'm really a classroom teacher. So that's been like, what the heck?
Right.
But it's all good. No big deal. Just can you see my screen?
Yeah, I can see. I'm just not really too fond showing my screen right now. I'm just kind of
Oh,
looking at this.
oh yeah. Don't worry about that. Don't
All
worry
right.
about like sharing your picture either. Like if you want, just to mess around with it, like when you do stop video, if you upload a picture, you can see mine. That's a little more professional, you know. So if you want to,
Right.
yeah,
I don't mind at all. I can still do it any kind of way. I can still see the problems right here.
good. All right, sweet. Yeah, it's different. That's for sure. Let's see. Yeah. So, well, yeah, we'll just wait. So if you want to mute yourself again, just wait while other people join, okay?
All right. I might as well like take a little nap. You can. I'll try to wake myself up.
Okay. Oh, that's adorable. I'll be like, hello. I could scream.
I'll try. I'll try to wake myself up. Thank you.
Yeah, you bet. Good morning, Patricia. How are you?
Can you hear me?
I can. Yeah.
Okay, okay.
You have 10 new messages. Tuesday, 5:28 p.m. Your local electric consultancy. Message deleted. Tuesday, 6:15 p.m. Message deleted. Tuesday, 7:33 p.m. Message deleted. Tuesday, 7:39 p.m. Message deleted. Wednesday, 12:47 p.m. The trip advisor called. Message deleted. Wednesday, 2:22 p.m. Message deleted. Wednesday, 6:31 p.m. Message deleted. Thursday, 2:28 p.m. Message deleted. Friday, 10:48 a.m. I'm a trip advisor called. Friday, 4:58 p.m. Message deleted. End of messages.
Hey, Adrian. Adrian, good morning.
Good morning.
Mhm. So Patricia, why don't you go ahead and turn off your video, and so that way it won't, you can have a little privacy.
Okay.
Yeah. Have y'all been faring pretty well? I'm a little claustrophobic right now. Kind of tired of being at home.
That make two of us.
Ugh. Yeah, I'm such a people person. This is hard for me.
I'm not a people person, but I like being outside.
Yeah, I'm glad the rain, but I'm wearing a sweater today now.
Yeah, I got on a hoodie.
Yeah, just like what the heck? The temperature change, not just the pollen now, it's gonna be a problem, right?
Yeah. And but Wednesday is supposed to be, I think, back up to 82.
Oh, Lordy. Well, it was It was a nice relief to get some rain last night.
Yeah. I didn't hear it, but
Yeah. All right, I'm gonna mute it again, just to do a couple of things before we get started. But I'll be back on shortly, okay?
okay.
Let's see. Okay, we got some more folks here. Hey, Seth. Tyson, nice to see you. I actually straightened my hair for y'all today. Woo woo. I was on some videos or some Zoom meetings yesterday, and man, I just wasn't feeling it. And I was like, man, I gotta do better for my students. There we go. It doesn't matter, but I'm clean, hair's done, all that. So we'll get started. We've got about 7 minutes if you have to go to the bathroom or get a drink or anything like that.
How are we going to get our old test back?
I might have to go outside. In the dark.
Oh shit, that looks cool. You don't need all that. Every last drop.
Yeah, that was shit. Just open the door. Hold outside.
Yeah, so I thought, you talking about
Hey, Jennifer. Hey, Alexis.
so you can make it fast.
Koya's.
Raya. Hi. Let's see. Who else? Who else came on? Oh, wow. 13. Nice. All right. So go ahead and let's see. So I have my video on just to demonstrate. We were on yesterday, some of us. I appreciate your help. There's a stop video. And so I just have a canned picture there, that the selfie that I took. Let's see what else. There's a chat feature if you have questions, but feel free to just unmute and do it that way as well. Let me get everybody listed again. So Koya, you're there. Hey.
Hey. Yes.
Sierra's in. Hey. Olivia. Hi. Tia, you're here. Hi. Evie's
Good
here.
morning.
Morning. Okay, so let's go ahead, because I know y'all have families there. Go ahead and mute yourself just so you won't have to hear the background noise. I can mute everybody as well if I need to, if you forget. I have teenagers, so they're asleep. Oh yeah, living a dream. All right, so I'll tell you what, go ahead and unmute. Let's talk it out. How did 9.1 go for you? Section 9.1.
Okay.
Pretty. It was okay.
Yeah, I was so happy to see that everybody was doing their work. So I'm just really proud of y'all. I know there's a few problems in there that are a little fuzzy, so I'm glad Patricia mentioned it yesterday, and I just thought we would just combine 9.1 and 9.2 today and just get started with that. Did everybody find the this document on D2L?
Yeah.
Okay.
What document?
I put it in the news feed, so you didn't have to copy. You don't have to copy everything down. It's there in the D2L course shell. So to just know that I'll be posting what we write here and stuff there as well.
Okay.
Yeah. Okay, let's see. So right now we're a little short. We've got 14. So somebody may come in. Let's book them in. Let's see. Nope. No, sorry, everybody. All right, so go ahead and turn your stop video so you're not showing Jennifer. And I'm going to go ahead and mute everybody. Let's see how to do that. Yeah. Well, yeah, if y'all don't mind, just go ahead and mute yourself so we don't get any background noise. All right, so the way this is working with our problems is we have a situation where, let me make sure I've got my pen. This one. Let's see. Okay. So where we have the radicals, and of course, if you have the square root of x, this is the same thing as x to the 1/2. And, you know, you do have the same rules that you've always had with square roots. If you have the square root of 4, you know, this is 2. But if you have the square root of -4, this is undefined. So you'll actually see that. I'm going to get better writing with this too, but right now it's a little sketchy. Yeah. So I just thought I'd set up some, you know, if we have an even power like this, because remember, this is the square root, so there's like a 2 there, we just don't write it like that. We can do the square root over everything because this is multiplication. So we have the square root of 36 times the square root of x squared, and so on. So anytime there's multiplication, you can do it. If there is a plus or a minus, you can do that. But this answer is 6x y to the 4th, z to the 3rd. And one way that you can always handle the exponents is whatever this number is here, and even if it's not written, you can just divide those in. These are all even. We're going to do some in just a moment that are odd. But the same thing happens over here, but the problem is that we have a rational exponent, and this is actually where section 9.2 comes in. And so we have to remember that 36 to the 1/2 and x squared to the 1/2, and then we've got y to the 8th, and so on. Oh, getting better at this. It's nice. Sorry, that should be a 2. This actually makes a little more sense, I think, in terms of if you remember that the rule of exponents, when you have something raised to a power like this, you can multiply these. You know, 2 times 1/2 is x to the 1st. 8 times 1/2 is y to the 4th. 6 times 1/2 is z to the 3rd. And of course, this is just square root of 36, you know, like we had over there. I find that the numbers are kind of easy in terms of that. So are there any questions about how that should work? You can unmute if you have a question. Okay. All right. So here we have a 4th root. So let me give you a minute to see if you can come up with that on your paper in front of you. See if you can get that done. Just so you know, if you need help with these, you can always, there is a 4th root under the math button. It's actually, you would have to do the one that says X root, but it is in there if you want to practice that. I prefer using my calculator, doing it this way, doing the 625 raised to the 1/4. You do need to put this in parentheses, but you could do it raised to the 0.25 as well. I prefer it that way. So does anybody want to unmute and tell me what they got for this? So Chen, you've got, you're unmuted. Do you want to answer it?
My answer is 5x
Yeah.
exponent 11,
Mm-hmm.
y exponent 14.
14. Okay. So how does that set for the rest of you? Hey, Harrison.
Yeah, I got the same thing.
Okay, good deal. And it's the same for both of them. You know, we've got this as going to be 5x to, and it goes, remember we're doing 44. Sorry, that looks like it's wrong. To the 1/4. And then 56 here raised to the 1/4. All right. So I'm glad that that made sense. Okay. All right. So with the odd power roots, you can actually take the odd power, the cubed root of a negative. That's no problem. And also under math, there is an option for a cubed root on your calculator as well. So see what you can get for these. So we should have -4 x to the 4th, y to the 11th. Any questions on those? So I combined 9.1 and 9.2 just using the rational exponents and the radicals. Radicals are 9.1, and I think everybody's done their homework for that. I was so pleased to see that. And here's the 9.2 with the rational exponents. Rational just means fraction. All right, so sometimes we're going to have rules of these radicals. This is also 9.1, where if they have the same radical, so the n is the same, you can multiply what's inside. And sometimes it makes sense to do it. So for instance, like if you have radical 3, so the square root of 3 times the square root of 12, it's going to be a decimal mess if you were to do it like this. However, if you were to use this rule, since the radicals are the same, just like we broke down those radicals up above, up here, where I could split this radical over each term since they're being multiplied, I can go the opposite way where I can combine them. So here I am where I have the square root of 3 times 12. So I'm doing it, you know, combining them. I'm actually multiplying. And so that is the square root of 36. Now that makes a lot more sense than having the square root of 3, because you can't break down the square root of 3 except into a decimal. And so we have 6. And here's a good example as well, where you can probably do this in your head. This would be the same thing as 800 over 8. So that's the square root of 100. A lot of it's just like with a lot of math. Sometimes for those of you who get math quickly, you'll probably be able to do a lot of these steps in your head. You don't have to write out all the work for it. You just kind of see it. But I did want to give you one that looks even kind of funkier in terms of how this works. So the 5th root of this, it just, I don't know, it just makes me unhappy to see it like this. So I don't like seeing the 5th root. I don't like, you know, that type of thing. But basically, remember how these work. This would be x to the 32 raised to the 1/5. So it actually, 5 does not divide evenly into 32. So that's why we know, okay, well, let's see if we can do something else. Since they're both the same radical, we would have this. So let me change this around a little bit. All right, so the rule of exponents is that, let me just put this up here. If you have division, like this, it's called a quotient in math terms. This is the same as saying x to the 32 minus 2. So that's x to the 30th. And anytime you have division like this, you will write it like that. So now we've got, so what questions do you have about this?
I can't see what you wrote on that last one.
Got it. It's off the screen.
Yeah.
Oh, okay. I see it now. All right. So let me just move it. Thanks for telling me. So this is going to be x to the 32 minus 2. And so this is the 3 x to the 30th. And then I do the normal way, and this would be x to the 6. That'll be my answer for that.
Do you only subtract the exponents when it's in division form?
Yeah, when it's that fraction, that would be the only time.
Okay.
Yeah, I decided to just put the book topics here, and it's down here number 4.
Okay. Those are the rules.
Yeah, those exponent rules. If you have, they have to be the same base, but yeah, that's the way that would work.
Okay.
I was started to type them all out, and then I just thought, you know what? I need to stop. Did somebody have a question? Sorry. Seth, did you have a question?
I had a question.
Yeah, I'm good.
Okay, go ahead.
Who's talking? Not someone else said something.
Yeah, do you have a question?
Oh yeah. So with this division one, you just dividing when you get 30, you just dividing that exponent 5 with that other 30 exponent, and that's how you got that 6.
Yeah. It would look like x to the 30th raised to the 1/5.
Okay.
Like that. So 30 times 1/5 is the.
Okay. Oh yeah.
Mhm. Now, the other thing that we need to know is that when you multiply the same radical, this actually, so let's say, as an example, we have the square root of 5 times the square root of 5. That is the same thing as saying like square root of 25. But probably what you remember from when you first learned this, it's been so long though, is that if you multiply the same thing, you just get 5, right? Square root of 5 times square root of 5 is 5. But it's this rule that we've been doing, multiplying underneath the radical, that is why. But in this case, we would have 13 times 3 is 39. And square root of 2 times square root of 2, this will give us a 2. So that would be 78.
Oh, wow.
So anytime you're multiplying the same radical, and we're talking about square roots too, we have that going on. But of course, on my math lab, the homework in 9.2, they have some really nasty fractions. And don't forget that when you're multiplying fractions, you can always use your calculator to change it back to a fraction. Like if you just blank out, just use your calculator and do the fractions for that. So I don't actually have, let's see. Let me just be on the, okay, so like, let's say I want to do.
Oh, where'd it go?
Am I on the screen in front of you? I stopped sharing.
Yes, you're, yeah.
Okay,
Yeah,
thanks.
on the screen for me.
Let's
Okay, there you
see. Let's say 6 divided by 7. All right. So this is what I've put on the screen. Let's see if it'll show. No,
Doesn't show.
it doesn't show. Yeah, I was okay. So what I typed in was, hold on. Yeah, I have to experiment with this. See if this will show better. Okay, let's see. So this is what I typed in my calculator. So 1/3 times 6/7. And when I hit enter, I end up getting this. I get 0.2857 ... So end up getting that decimal. But there's that button over here, right here, for math. And so when I click on that, I can actually, it'll take it to number 1. And it looks like a little sideways triangle to fraction. We've done this in class, I know. And it'll change it to 2/7. So if you're bad at fractions, you do have that option as well. So I know a lot of times with fractions, it's not so much that, I don't know, it's just a really strange thing. I think people just kind of freeze up on it. It's not that you can't do it, it's just that you kind of freeze up on it. So if that happens, you know, we have, you know, you have that option to deal with it. Are you seeing the work again?
Yes.
Yes.
Okay, good deal.
Yes.
Good deal. All right, so here here the next topic, and this is where we're going to start using a few of those details. Sorry, my husband is teaching. He's a fast texter. Oh, God, kills me. All right. So here we are. This is what I mean by what's common. So I just wanted to show you, kind of give you some of the bare bones. Like, this is how the rules of rational exponents, like what they mean. Where does this come in? But then here's our properties of exponents, and then here's some of the other work, and you know, that we'll be looking at. Okay. So let me give you an example of why you should care about these rules of exponents. So if I were to give you something like 32 to the, let's see one I can do in my head really quick. It's all about me. Just kidding. All right, so this is 3/5. 3/5. So when you're dealing with numbers, it's kind of nice, because then if I do the 5th root of 32, and this is to the 3rd power. So do y'all know what the 5th root of 32 is? Well, you can always put in your calculator, but 32 can be written as 2 to the 5th. And that's why I was thinking, oh, I'll do that quickly in my head. But so anyway, this is the same as saying 2 to the 3rd. Okay, because 2 is what's inside here. 2 to the 3rd, and so this is 8. Now, the hack you can always do with your calculator is you could always take a number and do that hat button, this little thing, and you could do 3/5. And it'll actually give you 8. It'll just generate 8, and that's pretty straightforward. So that's kind of where it comes in. But let me give you another one to do. Let's see. If I give you, let's see, 81 to the, let's say 5/4. 5/4. See if you can come up with that answer. And feel free to use your calculator. I used the radicals and just a moment ago. But if I wanted to, I could do it like this. I could do, okay, 81 to the 1/4 to the 5th power. So 81 to the 1/4 is 3. And then 3 to the 5th, that is, what is it, 243?
243. Yeah, I got 243.
Yeah, good deal. Now, with So really with numbers, doing these really makes sense. When we're dealing with variables, it just kind of is more busy work. You don't have to think about it too much. There's not going to be like a true false question, which is true, which is not. Okay, so here's just using some of these exponent rules, but we just have fractions. Let's go through these. We do need to talk about negative exponents like that and what that means, but this one right here is just straight multiplication. This is the same as saying x times 3/4 times 2/3.
Which give you 412, which gives you 1 over 2.
Yeah. So we're gonna have x to the 1/2. Yeah. So and again, if you wanted to, you could do that. The hack would be do 3/4 times 2/3, and you'll have 0.5 here in your calculator. So it's multiplied, and this is the rule that we have here. This one right here, number 2. Number 2 is your rule to do for part A. Now, anything to the 0 power is always 1. So even if there's something complicated, no matter what, it's going to be 1. Now, in your homework, there's a couple of trick ones. So let me show you an example. So let's say I have a negative out here, and I have, let's say, x cubed, y to the 7th, z to the 5th, raised to the 0.
Negative.
Yeah, exactly. So we end up getting, there's the negative out here, and then all of this goes to 1, okay, because it's raised to the 0 power. So that is -1 is your answer. So if that's the only way that it can be confusing, really, is just if you have a negative out front of it. Now, so that's a negative outside of the parentheses. Okay, what happens when there's a negative on this power? Well, let's see. It's like this situation here. You want to move it down to the denominator. So 49 to the 1/2, -1/2. We're going to move that 49 to the 1/2 to the denominator. And I would just get in the habit of just doing it straight out. Don't try and simplify it just until you get used to it. Now, this is the same thing as 1 over the square root of 49, which is 1/7. But, you know, the hack is definitely that you would have a situation where you could just type in 49 to the -1/2, and you can do that. Let me go in here, and I'm gonna mute y'all. I keep hearing some background noise. Good deal. So here we have a situation where we have a 5th root and it's negative. So these always make you think, but let's just take it step by step. So this would be the same thing as -32 x to the 10th, and this is to the 1/5. So remember, when we move it to the denominator, that power 1/5 becomes positive. Very, very important. All right, so now we need to remember that the 5th root of -32 is okay. Remember, if it's an even power, you can't take the even power of it, but since it's an odd, this would be -2. So we have 1 over -2, that takes care of the 5th root of -32. And then 10 times 1/5 is x squared. So what kind of questions do you have about that? Please unmute if you have a question.
I don't understand how you got -2.
Okay. Oh, and I see I've missed some chat box. I'm so sorry. I have not been recording this, but I will share this screen and I'll figure out the recording feature. Don't worry. So I'll tell you what, Patricia, why don't you take this and put this in your calculator? Do -32 and raise it to 1/5. What'd you get?
-2.
Mm-hmm. Yeah, so the math behind it is that -32 can be written as -2 raised to the 5th power. And then when we take the 5th root of it, then they cancel. That's the math behind it.
Okay.
What about the x squared? How did you, I know you got how to got the -2, but how did you get the 2 exponent with the x?
So how did I get these up here? Remember when we were doing these up here? How did I get x to the 12th? When I take the cubed root of it, oh geez. When I take the cubed root of it, how did I get x to the 4th?
You think you found the square root. Well, you divided it by 2 or
Yeah, this is the 3.
Or 3.
Yeah, so you got x to the 12th. You take the cube root of x to the 12th. And you've got x to the 4th.
Mm-hmm.
Yeah.
So you divided 12 by 3?
Mm-hmm. And look up here. You've got 4th root of x to the 44, and you get x to the 11.
Mm-hmm.
So 44 divided by 4 is 11. 56 divided by 4 is 14. So
Okay.
So for the variables, that's how you do it. The numbers, I think, are harder.
Mm-hmm.
I don't think you're sitting around thinking that the 5th root of -32 is -2. But with the variables, like once you get rid of this negative here, it makes it really easy. 10 times 1/5 is 2.
Okay.
And I would recommend getting rid of this negative power first. You could definitely do it differently, but I would recommend doing that first.
Okay.
We'll have opportunity to do some other stuff. All right. Let's see. What other questions do you have? I'm trying to. Am I recording now? Okay. I didn't mean to. I don't know. I'm looking up that recording feature. I appreciate y'all mentioning that. See if that's. I must be recording now. So, yeah. All right. So let's take a look at this one here. We've been dealing with 32 a lot. So let's see about how that works. All right. So here we have 32 to the 6/5, A 15 raised to the 6/5, and we've got B to the 75 raised to the 6/5. Remember, anytime you're multiplying, you can do it this way, where you just put the power on the outside out here. So 32 to the 6/5. Now, correct me if I'm wrong, but I think that's 64. Did you type it in? Let me double check.
Yep, it's 64.
Great, thanks. All right. Now we've got 15 times 6/5. I'm thinking that's 18. And then we've got B, 75 to the 6/5. So 75 divided by 5 is 15 times 6. I've got 90.
How'd you get 64 again?
Well, 32, fifth root of 32. And then you get 2. 2 to the 6.
Oh, okay.
64. All right, so take a moment, and I want to give y'all a minute to do this one. 81, A to the 16th, B to the 24th, all of that raised to the 5/4. Those of you who are quick with this probably were able to do the 16 times 5/4. So 4 goes into 16. 4 times 5 is 20. So you got 8 to the 20th. B, 24 times 5/4. 4 goes into 24 6 times. 6 times 5 is 30. Okay, that. And then 81 to the 5/4. Oops. It's 243. So those were like the last two problems in 9.1. But I did want to review that for everybody. Of course, those were radicals in 9.1, but it kind of gets into 9.2 as well. You should be set. There's a few tricky ones, like where the negative is, like whether it be a negative exponent or a negative outside the parentheses. So just make a note of that.
For that 2, what was that 2 something? I couldn't. The 243.
Okay.
I keep getting lost on, like, I know how to get the variables, how to figure out the variables, but I keep getting lost on the figuring out the whole number with that.
Yeah. All right, so try this. Try typing in 81 raised to the 5/4. That's the short way. It's kind of our little hack. What'd you get?
So raised to the 5/4.
Mhm.
Oh, 243, I got it.
Mhm.
I didn't press a button in my calculator.
Oh, no problem. No, but I think it's important to know that, you know, when you start doing these, it'll be, you know, you can do these like this. So 81, fourth root of 81 is what?
So I got to do 81 raised to the 4th.
Mhm.
81 raised to the 4th.
Isn't 81 3 to the 4th? So it should be 3.
Oh, 3.
Yeah. And then the way it works is you would then do 3 to the 5th. And that's 243.
Got it.
Yeah, so if you break it down in steps, you can't go wrong either. So I'm glad you're thinking about it. Now, what happens when in 9.3 when you don't have a perfect square? Of course, we can always find out what the decimal is of square root of 12, right? Go ahead and put down your calculator. Find the square root of 12. It's approximately, let me just type this in, square root of 12. It's approximately 3.464. In most math circles, this is not good. You never want to do that. You never want to, I'll use fuchsia to block it out. Okay, so you don't want to do that. Instead, what you want to do is you want to simplify it. So, and just bear with me here. What we're looking for these is a perfect square. When you talk about the multiples of 12, you got 1 times 12, 3 times 4, and what's another one?
6 times 2.
Yeah, thanks. All right, so which one has the perfect square in it?
2 and 6.
Yeah, I was about to say 2 and 6 as well.
So 6 is a perfect square if I took the square root of that?
No, 3 and
no.
4 because
3
4
and-
is a perfect square.
Right.
Okay, all right. So this is what we're looking for. What is our perfect square like that? So let's
4.
do 3 and the 4, yeah. So that's the one, but you can see that there are a lot of options, right? And so like when you get with a big number like 80, it's kind of the same way. So this is where we would then do square root of 3 times square root of 4. And so square root of 4 is 2. So this would be 2 square roots of 3. Now check that this is the same as what we found here. Put in your calculator 2 times the square root of 3. It'll always match up. If it doesn't match up, you've done something wrong with your simplifying it. All right, so with 80, there's a lot of options. But like probably one of the first ones you see, because we just had 4, is 4 times 20. And this will get you somewhere. Can y'all see that at the top of the page? Right?
Yes.
Okay.
Yeah.
So the problem is when I do the square root of 4 times the square root of 20, that's simplified, but I can still reduce square root of 20. So we gotta like come up with a different, let's come up with a different one. We don't want to do it this way. Let's see, if it's not 4 times 20, why don't you see what the higher perfect square would be?
5 times 4.
16.
16 times 5. Yeah. Now you could have just continued in this direction as well. So we could have the 2 square roots of 20, and then you break this down, and then you have 2 times square root of 4 times square root of 5, like that. You could do that, and then this is going to be 2, so you'd have 4 square roots of 5. You can do it that way. So if you happen to make a mistake on it, just go back and, you know, you can keep following this direction. But in this case, we're going to have, we'll do it all in one time. So we'll have the, we'll have 16 times square root of 5. So then that is 4 square roots of 5. Now I want you to check them real quick. What's the square root of 80? And then 4 times square root of 5. I'm going to do that too. All right, so 8.944. 8.944. Yep, they match up. Now, these are complicated enough with the square root. So what happens when you have the cubed root? So now we need to come up with a perfect cube that's the multiple of 81. And this would be 27. Some of these you're just going to have to try a little bit. But I just wanted to give you this example. This is the cubed root of 27 times 3. Excuse me, the cubed root of 3. So we'll have 3 cubed root of 3. Let me give you another one like that. All right, so let's do, let's see, color. Let's do the cubed root of 250. So see if you can come up with what that would be. And this is an even number, and 2 divides into it. So you got 2 times 125. 125 is the same as 5 cubed. So this would break down to be 5 cubed root of 2. Okay, so what do variables look like? We've already been talking about these, and they're a little tricky, kind of tricky to find. So if I were to just do this and have x to the 9th, that's 9 divided by 2 is not going to work for us. But if I were to set this up, I'll have more room down here. If I were to set this up to do what the perfect square is, x to the 8th, and then I have 1 extra over here. And then if I use just y to the 10th, and I have 1y left over, and then z to the fourth. So if I have the and one z left over. Then I could break this radical right here, break it apart right here. And I would have x to the fourth, y to the fifth, z squared, and then under my radical, I'm going to have x, y, z. And so this is my answer.
So you just divided it looks like you divided that 2 into all of them on the
I did.
outside.
Yeah, just like what we did up here in 9.1 when we were, you know, let me move it up here. We did the same thing.
Okay.
Okay. You have a 4 here. You divide it into 44. You get 11.
Mm-hmm.
And so we want those where they actually do go evenly. So you have it like that. Now, I think the cubed root when you're dealing with variables is a little bit easier because you're looking for things that 3 divides evenly into. So see if you can get the answer to that. And I always like to set mine up like this, where I know that there's 7, but 6 is the highest number. So I'm going to do 6. I'm going to have 1 left over. And then with y to the 16, how many should I have here? Does anybody want to unmute and tell me?
15.
Okay. And if I had 15 here, how many am I missing?
1.
Yep, just one of them. All right, so I'm gonna break it right here. Cubed root of x to the 6th, y to the 15th. That's gonna be, just divide x squared, y to the 5th. Then I have what's left over, just this extra over here, x, y. So that's my answer. What do you think? You think you can try this one? This is the square root. See if you can come up with what we would do for that.
Which one?
This one right here, square root of 25, x cubed, y to the 8th.
No.
So I know 25 is that's a perfect square. So that takes care of this one. X cubed. So I know 2 of them would work. I'm going to put an extra one over here. So that takes care of the x cubed. Now y to the 8, that's all of them. Because 2 goes evenly in 8. And I know that some of this is really fuzzy. So don't let me give you the impression that I'm trying to minimize the struggle, but I just wanted to just talk it out. But yeah, just take some practice. So this is the same thing as saying 25x squared y to the 8, all under 1 radical times the square root of x, okay? So then this radical is 5x y to the 4th, and square root of x is still there. So if you can keep up with them, then you'll be good to go. And this 4 looks like it's a little bit over that radical. So let me take that off real quick. Sorry about that. My writing's just a little bit off. So the 4 should be on the y like that. Okay. Okay. So let's take a look at this x cubed one, the cubed root, excuse me. All right, so unmute if you want to participate. So 3 goes into 12 evenly. So all of the x's are here. Now, tell me how many y's do we need?
2.
So does 2, is it divisible by 3?
You need 3.
Okay, yeah, let's do the 3. Now, if I have 3 here, how many do I need over here?
2.
Yeah, thanks. And what about z?
Stays the same.
Yeah, none of those work. Okay, so again, I'm going to break it down right here. This would be cubed root of x to the 12th, y to the 3rd, and the cubed root of y squared z. Now, this one can be broken down. Oop. What should that be? Not 12.
4.
4, exactly. Y should have just y, right? And then what's left over here is y squared z. All right, now I'm gonna put this one in the notes. I'm not gonna do it right now, but it's a good practice one for you to do later. I wanted to talk a little bit about adding and subtracting radicals.
Do you mind scrolling up a little bit for that last problem?
Sure.
Thank you.
Yeah.
Okay, thank you.
Yeah, you bet. So for these, when you add or subtract radicals, you need to think about this square root of 5 like you would x. If you were to have something like 3x plus 6x, you know, because you're good at algebra, it'd be 9x. Well, radicals are the same way. But as long as they match, you would have 9 square roots of 5. And you can type this in. You can type this in just like it is, and then put in 9 square roots of 5, you'll get the same decimal. The same is true here. If we had 7y minus 15y, hopefully you know that 7 minus 15 is negative 8. Y in the y space. The same thing happens here. This would be negative 8 cubed root of 2. So that's what's going on with all of that. And we'll need to kind of stop here. I do, because I know some of you probably have some questions for me. And you probably have another class to go to as well. So I just wanted to pause, just like usual. In a way, I don't want to finish the section because I don't want to make it do homework. I want you to try it. But just real quick, the way you would do something like this is you've got to break it down. So I put here, you must simplify first. So this would be 9 times 2, the square root of 18. So that's 3 square roots of 2. You'd break the square root of 8 down, and so on. And, you know, this one is 25 times 2, which would be 5 square roots of 2. So for those, I think for your homework for 9.3, you could go ahead and get started, but it won't be due Thursday night. It'll be due next week. All right. So from there, I'm gonna stop this, and I want to give you a chance